let's assume that we have a force given in Cartesian coordinates, which is y squared z cubed minus 6xz squared. That's the x component. The y component is 2xy z cubed. And the z component is 3xy squared z squared minus 6x squared z. And we want to see if this is a conservative force field. So there are a number of ways we can do this. One is to check whether or not the curl of this is equal to 0. And that looks like, so in Cartesian coordinates, we have I hat, j hat, and k hat. And the components of the curl are just partial derivatives in that component. And the components here are y squared z cubed minus 6x z squared, 2xy z cubed, and 3x y squared z squared minus 6x squared z. So let's evaluate this. So we have an x component, which is just a result of this line. We're doing the determinant. So we have derivative in y of this, of the z component, and that looks like 6xy z squared. So that has an I hat associated with it. Then we have this line, so it's a partial z of this in the y direction. So that looks like plus 3y squared z squared minus 12xz j hat, and then the last one is this partial x in this, which gives us a plus 2y z cubed k hat. And now we'll do the next line, this, and that, and with minus sign. So we have a minus. We should have exactly what cancels with this when we do the partial y with of this, partial with respect back to y of this, k hat, we should get this. And in fact, we get, 2y z cubed k hat. And now we'll do the partial x of this term in the j hat direction. So we have, and that's going to give us and we have a minus, so we have 3y squared z squared minus 12xz, which is in fact exactly that. And then the last term is we have in the I hat times this times this times that. So it's derivative of z of with respect to z of this, we'll get a z squared, and that's what we have here. And so we have a 6xy z squared I hat, and we can see that that is in fact equal to 0. So it must be true that f is equal to minus the gradient of some function u. So we could evaluate what this is, right? Du by dx, so the gradient of u, right? D by dx, du by dx I hat minus, what is this? See, we have a minus sign well, this has to be y squared z cubed minus 6x z squared. And du by dy has to be, it has to be this with a minus sign, minus 2xy z cubed, and du by dz has to be minus that for f to be related to u in that way. So this has to be minus 3xy squared z squared minus 6x squared z. And so if we integrate this one in x, this one in y, and this one in z, we'll get u. Here we'll get up to some constant, some function of y and z, because we're integrating in x. This one some function of x, and so up to some function in x and z, and this up to some function of x and y, and then we'll see what these functions have to be. So we integrate this, and this tells us that u is going to be minus xy squared z cubed plus 3x squared z squared, plus we have some function. This could be some function of y and z. And then from this, we can say that u is minus x y squared z cubed, integrating this, plus some function g of x and z, which has to be compatible with this one. And from here, we'll get u is equal to minus x y squared z cubed plus 3x squared z squared plus some function, at most some function of x and y. And so we can see that x and this g here is really the same thing here. And so there is no yz kind of thing here. So all of these together are compatible if u is equal to minus x y squared z cubed plus 3x squared z squared plus just some number, right? No function of x, y, and z. And so that's the potential energy function.